Welcome to everyone dialing into the call. We're going to be kicking things off in just a few minutes as we wait for more people to join us. Please introduce yourselves in the group chat and also mention where you're dialing in from, as we've got people joining us from all different countries and time zones today. It's coming up to the hour now, so we're going to get things kicked off. If we can go on to the first slide, please, James. Firstly, I'd just like to reach out and give a warm welcome to everyone on the call. It's really great to see so many people here from across the transport and energy sectors. And we're here today discussing bidirectional vehicle to everything, or V2X charging, and the roadmap of actions needed to unlock the full potential of this technology at commercial scale. My name is Goldsmith, and I'm head of Grid and Data Services at ev.energy, and I'm hosting the webinar today. We've got a really exciting agenda for you, where we're going to be sharing learnings from our V2X Flex project, including the newly published V2X white paper. This has been created with over 40 hours of industry interviews with EV experts from around the world. It was also got a really strong focus on the consumer journey, which is supported by some world-leading consumer research from the Energy Systems Catapult. So to tell you a bit more about the V2X Flex project, it's part of the V2X Innovation Programme, which is funded by the Department of Energy, Security and Net Zero and delivered by Innovate UK. And this project builds on ev.energy's world-leading smart charging platform, incorporating bidirectional charging technologies to unlock an exciting new range of EV charging products and services. As a global EV charging platform, ev.energy works with charger manufacturers, vehicle OEMs, and energy utilities to connect electric vehicles with the smart energy grid. Collaboration and alignment are really key to delivering successful innovation, and I've been really thrilled that we've delivered this project with such a great range of partners. So as well as the Energy Systems Catapult, we're working with Indra Renewable Technologies and Wallbox, who are both leading charger manufacturers in the bidirectional space, and on the OEM side, collaborating with Volkswagen, Stellantis and Nissan. Joining me today, we have a star lineup of industry experts, including Nick Woolley, Giulia, Escher, and Joe Stilin from ev.energy. If you're not familiar with ev.energy, we're a global EV charging platform used by over 100,000 electric vehicle drivers and more than 30 utility companies across Europe, North America, and Australia. We also have Danica Caiger-Smith, who is the consumer research lead at the Energy Systems Catapult. The Catapult is an independent, not-for-profit centre of excellence that bridges the gap between industry, government, academia, and research, and they take a whole system view of the energy sector, helping to identify and address innovative priorities and market barriers in order to decarbonise the energy system at the lowest cost. I'm also really delighted to welcome Sophie Randall, who is Innovation Lead for Mobility and Cities at Innovate UK. So welcome, Sophie. Innovate UK is the UK's national innovation agency and supports business-led innovation in all sectors, technologies and UK regions. They also foster international collaboration, and other innovation agencies work with them around the world. We have an exciting agenda today, starting off with introducing V2X and how the ecosystem connects. We're then going to be sharing some consumer insights from our user research with the Systems Catapult, along with an 8-step roadmap for industry actions to unlock V2X at scale. Finally, we're going to focus on how to drive forward V2X innovation and how this can be spread from the UK to other markets across the world. There'll be a Q&A session at the end, and as we go through the webinar, please post your questions in the group chat. We're also happy to continue these conversations offline if you want to email innovation@ev.energy with any additional questions that you have. So let's start things off with Nick Woolley, who's CEO and co-founder of ev.energy. So a question for you, Nick, is bidirectional V2X charging an evolution or a revolution?
Thank you very much, Will. Great to be here. So I think bidirectional charging is very much an evolution of existing technologies, but there are some revolutionary components within that. So at ev.energy, the way that we think about the transition towards bidirectional charging is by classifying charging into 5 separate types of levels, 5 levels of smart charging. So before smart charging, level 0, which is outside of our 5 levels, is unmanaged charging. And a lot of charging at the moment happens as unmanaged. Electric vehicles come home, they typically plug in on the energy system at about 6 p.m. and they charge as soon as they connect. And that's unmanaged and bad for the energy system. It's also bad for consumers' wallets too. And we think about 60% of charging happens in that space today. The first level of managed charging is what we call level 1 grid-friendly charging. It's mainly grid-friendly, but it does have its drawbacks. So the way that this works is typically consumers come home, plug in, but they've set timers, static timers in their car to charge at certain times on the grid. And one of the big drawbacks of this is that oftentimes people set timers at exactly the same time. So in California, where I am today, all of the electric vehicles come and charge on the grid at about 11 p.m. And that means there's this big secondary peak on the energy system that's very difficult to manage. We think about 25% charging is happening there today, and long term, we don't think that's a tenable solution for where electric vehicles will be charged in the future, because they have to be integrated more dynamically into the system than that. And that's where level 2 and 3 really come in. So level 2 is where we're controlling the electric vehicle for the benefit of the grid, and we're responding in real time to dynamic signals on the energy system. So we're understanding what's happening at the local grid transformer and on the local energy system, and then we're controlling and managing according to that. And level 3 is where we bring in the home as well. And so we integrate solar panels and we understand local renewable generation, and we bring that all together to optimize alongside the grid requirements as well. And that's where ev.energy is playing a lot of time today, and that's where our 100,000 drivers are today. The next evolution to that sequence is smart bidirectional charging, V2X, and then also full V2X that goes onto the grid. So V2G plus optimizing for the grid and also the home, but for export now. So instead of just pausing charging and delaying it to when the best times are for the grid, we're now actually exporting energy back onto the grid, either into the home to support the rest of the devices within the home or onto the energy grid itself. And that's really exciting. Not a lot of charging right now is happening in that space. We are doing exciting work on it, and we'll talk about that more today. But in the future, if we get the business models right for this space, this could be a really big and important part of the way that electric vehicles are charged, and really beneficial to the energy system as well.
Thanks for taking us through that, Nick. So bidirectional V2X is part of this broader spectrum of smart charging technology with some really interesting use cases coming up around vehicle to home and vehicle to grid. Why is it that you think bidirectional charging is so important from the perspective of electric utilities? And what impact do you think that this export capability can have on the grid?
Yeah, that's a great question. So maybe I'll help answer that question with the use of this slide, which describes a few different scenarios as to what will happen to the energy system under different levels of smart charging. So there's 3 lines on this graph, and what they depict is the change in peak load on the energy system under different levels of smart charging. So if I take you through the top graph first, the top line first, that's unmanaged charging. So that's when electric vehicles come home and they plug in immediately. What you can see is a really big increase in peak demand caused as a result of that unmanaged charging. This is for a typical energy system. It's modeled on the UK, which is roughly the same size as the Californian energy system as well. It's lots of systems are kind of this big. And this is actually like almost a 50% increase in peak energy consumption, which is really quite difficult for grid operators to manage. It kind of peaks around 2040, which is when we expect lots of electric vehicles to be available on the grid. The second line is where we are actually doing that optimized charging that we talked about in levels 2 and 3, where we're doing smart and managed charging. And you can see that the graph is about 50% less of the first graph in terms of total increase. So it's better for the grid. We're delaying charging now for the times when the grid has capacity available, has renewable energy available, at the prices are lowest as well. So that's really, really good for the grid. But it still creates quite significant peaks on the energy system because we're still taking energy from the energy system at peak times, and that is necessarily increasing our overall loading. The final graph is where we're actually introducing vehicle to grid technology. So now what we've done is instead of just building a virtual power plant of devices that are taking energy from the grid at certain points in time and managed according to the grid's requirements, we're also using those devices to export energy back onto the grid. So we've effectively built this enormous virtual power plant, just like a traditional power plant of today, like a nuclear power station, and we're using that energy to help manage the grid. And what the interesting thing is of the last line is that you see that the overall impact on peak loading, well, there isn't an increase in it. It levels out around 2040, which is very exciting. So from a power system operation perspective and an energy perspective, the potential of vehicle to grid is to help balance the system almost in its entirety if we get this working in the right way for energy utilities.
So this is a really exciting challenge, which brings together transport and energy as we start electrifying transport and more electric vehicles come onto the roads. How is EV Energy helping to connect these two sectors, and what does the value chain look like?
Yeah, so what we've just taken you through is actually a lot of the technical challenges and the technical opportunity. But one of the biggest challenges is actually bringing together the wide variety of stakeholders that exist within the ecosystem. And we think about this all the time, building a business in this space, and it's really, really important to ensure that we're creating value across the value chain and not so that we can bring everybody with us and we actually and we're incentivizing everybody to operate in the right way. And so there are 5 different key actors that we think are really, really important in this space. The first is the driver. The driver has to be brought on side with all of these technologies. Fundamentally, they bought an electric vehicle to drive their electric vehicle and make trips to different places. And so we need to ensure that their electric vehicle is charged for when they need it, and they need to do that reliably, and it needs to do that in the right way for their pockets as well. So it's rewarding them for doing the right thing on the energy system. So we think a lot about the driver because the driver is absolutely key to the mass adoption of these technologies. The next 2 are around automakers and charger manufacturers. So these are the hardware devices that are in the ecosystem that are really critical to enable technologies like V2X to work. So automakers, we need them to have the right capabilities within their cars so that we can connect to the cars and that we can control and manage charging. And then we can also do V2G and connect those chargers that are capable of doing V2G and export energy into the home or onto the grid. Charger manufacturers too have a massive role to play in terms of the infrastructure that connects to the other end of the cable. And we need those technologies to be brought forward so that we have widespread adoption of vehicle to grid technologies at prices that consumers are willing to pay. And then, of course, each of those hardware devices, there are going to be many makes and models. There's going to be lots of choice. We're in a competitive market. And so oftentimes in those kind of spaces, you need platforms to be able to aggregate all of those devices together to then provide a service back onto the other key actor in this space, which is the electric utility. So EV Energy's role is really to play that platform role that bridges between automakers, charger manufacturers, and the driver and create a single pipe for energy utility so that they can control and manage all of the electric vehicles on their grid, whether they be doing level 2 or 3 dynamic smart charging or levels 4 and 5 active vehicle to grid charging in the future. They can just control and manage them according to their requirements to remove grid congestion, to increase the use of renewable energy, and to also reduce power prices for everybody to help us all to save in the value created from vehicle to grid.
Thank you, Nick, for talking us through that value chain and also highlighting the importance and the real opportunity here around V2X. I'm now going to hand over to Giulia Escher, who's the Energy Flexibility Technology Lead at ev.energy. Giulia, what are some of the key use cases and different types of V2X that exist?
Yeah, thank you, Will, and hello, everybody. So there are three different types of V2X. Vehicle to home, V2H, vehicle to grid, V2G, and vehicle to load, V2L. So Nick has already touched a bit on some of these, but let's go through them with a bit more detail, particularly from the point of view of what the user advantages are. So vehicle to home, it's like to understand it, consider the example. So I'm a driver, I come back home in the evening, I've probably just commuted for say an hour, a couple of hours, there is still residual charge in my car battery. And when I come back home, the electricity prices are at peak, they're likely to be quite high. So I, as a user, can use my residual battery charge to power my home. And then I can recharge the battery in time for tomorrow when I need to use my car again for traveling with very cheap tariffs during, say, overnight. So from the point of view of the user, this is the mode that really maximizes the savings for their energy bill, because they're charging at low prices and then they're using their battery in their car to power their home. So they don't need to import quite as much electricity, and definitely not the kind of very expensive electricity at peak. V2G takes that a step further. So not only maximizing the savings on the energy bills like V2H enables you to do, but also actually earning money by being able to sell electricity back to the grid. So the way this will work is, again, you will charge the battery of your car when the electricity prices are low. And then when the electricity prices are high, there might also be export tariffs, for example, that will have a significant value, and you can sell the electricity back to the grid and earn money through these export tariffs. If the utilities, if the suppliers expose these sort of export tariffs to the consumers, but also potentially as a service to the grid. So, for example, the user could earn money as incentives, like ev.energy proposes, by selling electricity to the grid when the grid needs it, for example, to provide a service to local system operators. And then finally, we've got vehicle to load, which is basically backup power supply. What does that mean? So the car can act as a backup generator in the case of your home getting disconnected from mains because of a power outage. There have been already quite a few trials for this. There's a particularly interesting technology in the US because obviously there are some more incidents of power outages because of storms or extreme weather events. And what has been observed is that actually the car battery can power the home, or like the circuit, emergency circuit connected to the car for quite a long time. So it's really useful, and especially for a certain category of users, like vulnerable users that, as you can imagine, might have medical equipment that has to be on constantly, and particularly has to stay on even during a power outage. So your car could help during that. But it can also have other applications, like, for example, on the go, if you're driving your car to a camping trip and you can power your off-grid cabin, or just use it to, boil your kettle to have a cup of tea. So lots of different and varied users. The kind of thing that is in common for all of these is that managed charging, or smart charging, is really essential to maximize their potential. Because if you imagine vehicle to home, vehicle to grid, but also vehicle to load, it needs to have a user interface that will collect the user preferences in terms of what their tariffs are, when they need their car ready, what the level of charge they need. And thanks to smart charging, the users can just forget that, just set those settings, and then let the smart charging platform take care of all of this and really optimize the schedule for the tariffs, the grids, and what the user needs.
We've got some really compelling use cases there, Giulia. Thanks for explaining those in such clear detail. I guess in terms of enabling this from a technology perspective, when we talk about bidirectional charging, there's some additional complexity. with V2G, for example, versus V1G or one directional smart charging. I was wondering if you could talk us through the components of the technology ecosystem and describe in practice how these things connect.
Yeah, I mean, as you can see in this slide, there is a whole ecosystem that connects that has got some similarities actually with the one directional charging. So it's not a complete revolution, but obviously there are some aspects of it that are different. And really the key to navigate those will be interoperability. Interoperability specifically to start with, within the communication from the between the charger and the EV comms controller, so between the charger and the electric vehicle. We've seen there so far, for example, bidirectionality has been kind of pioneered in terms of charging standards by Nissan with the CHAdeMO standards. However, kind of CCS has been the internationally, at least the most sort of established and widespread charging standard. So we'll see, I guess, in the future, or in the near future, hopefully, with the development of what we've highlighted here in the slides of the ISO 15118 protocol, hopefully kind of defining a particular standard that all chargers can use there will really enable bidirectional communication and hopefully unlock some of the obstacles that we've seen so far with V2X. But kind of taking a step further, so in terms of not only the communication between the charger and the vehicle, but also how we do smart charging, alongside interoperability, having upstream of that an EV charging platform, which is the role that ev.energy is taking, allows also a better consumer experience. So I mentioned again interoperability because like what we ev.energy is trying to do is basically connect with any charger, any vehicles, so that the user can swap their charger and still being able to use the same charging platform, not having to kind of learn to use a new completely different app. And it doesn't even require an extra piece of hardware. So you've just got your charger, you can connect to ev.energy or another EV charging platform without having to install and pay for another piece of hardware on top of what you've already bought. And again, in terms of interoperability, there are some standards there in terms of how we communicate with some of our assets. For charger management, for example, the OCPP standards has been particularly widespread, but there are also some other applications, for example, mostly in the US with the IEEE 2030.5 standards. And we also tend to talk with vehicles, so not only chargers, again, interoperability. However, I guess the standards and the protocols there have been a little bit more bespoke to this date. But I mentioned also consumer experience, so not just the control of the charger, and but also how do we show that to the user? How do we get the information that we need from the user? And that's for that reason that an EV charging platform will have an app, normally a driver interface, where, as I mentioned before, we can find out when the user needs their car ready by, if they've got any settings, for example, they don't want to charge at a price higher than a certain amount, and all of that, and obviously the tariff, because as I said before, our top priority is to save money for the user. But that said, the priority is, charging the car. Definitely want the user to have the car charged when they need it, and we want to do it at the lowest possible cost. But that's not the end of the picture, because the role of the EV charging platform is also charging that car at the right time, as Nick mentioned before, to turn sort of that challenge of EVs taking on the market into an opportunity for the grids. And we do that by integrating also upwards with utilities. So we have all these EVs on our platform, and we aggregate them and take them and make them participate as one into flexibility markets. And that can be, for example, like system operators in the US, or like in the UK, or communicating with utilities in the US. And on that kind of interface, we've seen some standards emerging. So again, in the theme of interoperability, we've seen things like OpenADR and again, IEEE 2030.5 that have been used for some applications, some proof of concepts. But sort of to this date, again, sort of there are a lot of bespoke protocols, and it is likely to stay like this for a while, probably, because as you can imagine, there is quite a lot of variability with the markets that can exist in different countries, regional versus national, and so on.
Thank you for talking us through that ecosystem, Giulia. It's really great to see some of those international standards developing, particularly around the car and charger, and but also kind of understanding the challenges, and that having one standard to rule them all is probably a very unlikely outcome. But the more we can kind of align and harmonize across the value chain, the better overall experiences we're going to be able to deliver, the better outcomes as well for V2X. So we've talked now about V2X from an industry perspective, but what do consumers think? So talking next, we have Danica Caiger-Smith, who is the Consumer Insights Lead from the Energy Systems Catapult, and has led on some world-leading research into consumer attitudes towards V2X technology and propositions. So now over to Danica. We'd really love to hear about some of the findings from your research.
Thanks, Will. So yeah, first of all, it's worth saying one of the things that was really important to us is making sure we were representing the views of mainstream consumers as well as early adopters. So for these interviews, we spoke to some people who already had EVs, a couple who had ordered them and are still waiting for them to arrive. Hopefully they've got them now. Others who are open to an EV but not ready just yet, and actually one person who was really reluctant to move away from her petrol car. And we talked about V2X generally as a concept, as well as breaking it down into vehicle to grid and vehicle to home services as well. There's so much detail I'd love to be able to share, but to keep it kind of brief, I'll use this structure. So obviously there were things that people liked and things that they needed a bit more reassurance on. And we can roughly split those into kind of broader environmental and societal factors and more personal factors as well. So looking at kind of environmental and societal factors, people saw V2X as like, it's just a no-brainer. So they saw that EV drivers could benefit, but also they were doing something for kind of the greater good. So for some people, that was the planet, the environment. For other people, it was doing sort of the greater good for the grid as well. And against the backdrop of sort of high energy prices and concerns about energy security, it was just seen as a really sensible, pragmatic solution. On the downside, against that same backdrop of high energy prices and concerns about energy security, actually some people were really reluctant to commit to anything energy related. And there's this kind of perception, we see this in a lot of our research at the moment, that there's sort of a feeling of instability and uncertainty in the energy market and in long-term policy. And people don't want to make decisions that might commit them to something that actually turns out worse in the long run. And then looking kind of on a personal level, so people really easily recognize the opportunity to save or even earn money by charging at off-peak times and using or exporting that cheap green energy at peak times. It felt really intuitive to people, and even people who'd never even thought about having an EV, that kind of resonated and they could understand it quite easily. And those that we did speak to about their energy use, they were really conscious of reducing their carbon emissions, and were trying to balance that with reducing their energy bills as well. So actually this felt really relevant. People also felt that V2X, they kind of expected that it would be really easy to use, and it wasn't necessarily a benefit that we highlighted. People kind of picked up and were really positive about that anyway. Particularly those who were already putting quite a bit of effort into managing their home energy technology. So people, for example, that had solar panels or batteries, actually they really welcome the idea of a service that would help them get the charge they need for the best price and lowest carbon, but actually without the need for lots of manual control on their part. And that kind of the appeal of automation was largely about making it easy, but there was also this appeal in automation being able to access better cost and carbon savings than a person trying to do it themselves. And actually some of those people we spoke to who did have EVs pointed out like instances where despite their best efforts, actually they hadn't got the savings they'd expected, or actually they'd set their charger for the wrong time and it ended up costing them more than they'd wanted. So yeah, there's a feeling that automation like enables you to get more savings than you might be able to yourself. One of the key concerns that we heard about was relating to a lack of control, though. So some people did worry that actually grid needs would be prioritised over their own, and they might be left without the charge that they needed. So like this person in the quote shown on the screen, they were really concerned that actually grid needs might take priority and they'd be left without charge. We introduced kind of the concept of, you know, if you could set a minimum level of charge and a time by which that's needed and you're kind of guaranteed that outcome, how do people feel about that? And that went some way to reassuring people, but they were a bit concerned about how that would play out in reality. And some people pointed out that just one instance of not having the charge you need is enough to really impact your trust. And there was a great quote from someone who said, it's like going to your favorite restaurant and having a really bad meal. Like the fact that you've been going for years and having a great time, that kind of goes out of the window if your most recent meals let you down. And then obviously cost of installation. I mean, finance is a big barrier, especially if people don't have an EV yet and they're looking at this on top of the cost of an EV. For most, what's really encouraging is actually it wasn't a total turn off. So kind of they'd want to know the payback period and when they'd start to see some of the return on their investment. And there was recognition that they might be able to access more savings quicker. But some did also question whether the money might be better spent on something else instead. So actually this is, you know, competing with getting a domestic battery that would spend all of its time at the home, and people were questioning whether that might represent better value for them as well. But there's some really good opportunities highlighted as part of these interviews. So there's an opportunity for a service that includes vehicle to grid and vehicle to home as a continuum. So actually we introduced them as separate concepts, but then when we asked people which they'd prefer, several people said, well, why would I need to choose? They kind of felt that they were extensions of the same principle and they'd want a service that did both. So they kind of saw it as they use their car battery powering their home first, and then if they had surplus that they could export, then it would do that. So something that encompasses both might be really appealing. We talked about bundle offers as well. So people recognise that V2X could have quite a complicated supply chain, and also one that's unfamiliar for people that don't have an EV. You know, they don't know how to choose an EV. They might feel uncomfortable sort of navigating the choice of chargers. So actually a bundle that offers, for example, an EV lease alongside charger installation and spreads the cost of that across the contract, and access to a V2X service could help people navigate the different options available to them, helps remove some of the hassle and some of the perceived risk of taking up that offer. Obviously, that's not for everyone. Some people will always prefer to get things separately, but actually several people were really open to this idea and actually willing to pay a little bit more for the convenience. So there was a lovely quote of like, you know, it's not going to be the cheapest, it's not going to be the most expensive, but actually paying a little bit more to have this nice package with a bow on it and having someone help you through the process might be really appealing. And actually some of the people we spoke to who didn't have an EV reflected that actually this could sort of speed up their transition to an EV, sort of represents additional value from the car. It becomes more than just a car, it's kind of part of your home energy system. It could help you access better cost savings and reduce the payback period as well. And for those who feel a bit uncomfortable again about sort of navigating that unfamiliar space, you know, there was one quote from someone who had an EV and had had one for years. His mother is in her 70s and would love one, but feels a bit uncomfortable about using the technology and kind of not confident in her ability to be able to set up the charger to get what she needs. So there was this idea that actually it could help people, you know, have confidence in being able to use their car and charge their car the way they need. And again, bundled services could help navigate all those choices and decisions that people make as they move away from petrol and diesel and move to EVs as well. So that's a really high level overview of some of the findings from our interviews. We have run a survey as well that went out to our own panel, as well as some ev.energy customers in the UK, and looked at people's reactions to V2G and V2H propositions. So watch this space, there's plenty more to come.
Brilliant, thank you, Danica, and some really great insights shared there. I think that really highlights to us the importance of considering consumer needs when designing V2X propositions, which is exactly what we've done and the approach we've taken when trying to build out the actions in the white paper and the service we're looking at. I think also what we're keen to do and develop on this going forwards is look at different comparisons. So a lot of this has been UK focused, but in the US as well, we've got a lot of different customer types and segments, and actually no one solution is going to be right for everyone. So how can we understand those different consumer needs and make sure we've got solutions that work for a range of customers? So with all those consumer insights in mind, we've really focused our industry roadmap around 5 steps, which we've identified as needed to overcome the challenges to the consumer's V2X journey. So when looking at barriers, we've framed that in thinking about the consumer's journey when they're looking and investigating V2X. This is something they want to do. How do then they go about purchasing a charger or getting it installed? And then what's the experience of using and running through that product? So I'm going to talk through these 5 steps and then introduce the 8 industry actions that form up the V2X white paper and how they link in with this consumer journey. So the first step, step 1, is attractive compensation. And to get consumers interested in V2X, we need to offer them an attractive incentive for investing in the technology. So as the consumer research has shown, there's a lot of different consumer benefits for V2X, whether that's carbon savings, convenience, but really what's come out of the research is that financial incentives are still the biggest motivator. To make V2X attractive, we also need to ensure that the financial benefits deliver return on investment for these consumers. So to reach scale, unlocking that value is really important. The second step in the consumer journey is ensuring affordable and available charging equipment. So consumers need an easy and affordable way to buy V2X capable hardware. As mentioned, the upfront cost of installing this hardware may not be prohibitive for early adopters who might be more affluent and have spare cash, but there's definitely a need for different business models with leasing or financing options to ensure that this technology is open to a wider range of customers. In the market today, there is still quite a limited availability of bidirectional charging hardware outside of trials, but it's really encouraging to see so many charger manufacturers, such as Indra and Wallbox, now offering bidirectional EV chargers and building this into their core product offerings. And we're seeing more and more of these products starting to get announced and come onto the market. Vehicle OEMs also play a really important role in this space and are starting to make bigger moves into bidirectional charging. So in the US, we saw Ford launch the F-150 Lightning last year with a vehicle-to-home off-grid backup power supply solution. Hyundai are also following suit and advertising vehicle-to-load and vehicle-to-home with the Kia EV6. VW are marketing bidirectional charging capability with their full ID range, and really exciting to see that begin to roll out. And Stellantis as well have been doing some really interesting V2G trials with their Fiat 500e in Europe. So a lot of positive things happening in the space from a hardware perspective, and we're looking forward to see more of those come onto the commercial market soon. The third step in the consumer journey is ensuring the safe operation of the battery vehicle. Safety is obviously of primary importance, especially to electric utilities when it comes to putting power back onto the grid. And battery health is also a key concern for automakers and got brought up a few times in the consumer trials. These kind of important areas of safety and battery health are things ultimately that consumers want other people to take care of for them and don't want to have to worry and stress about themselves. So in the roadmap, we point out how these risks can best be mitigated and who needs to work together to solve this solution from a consumer perspective. 4 out of 5 is ensuring a seamless user experience. So once you've got the financial case together, someone's made the purchase decision for V2X, they've got a charger installed, it needs to be really easy for consumers to use. During the consumer research we did, one of the responses that particularly stood out is when we asked someone how long it took them to charge their car at home, they answered 10 seconds, you just plug it in. And we've spoken today quite a bit about automation, and really that is the optimum. You're not standing there waiting at a public charging point for it to charge. You can rock up, plug your car in on your driveway when you get home, and the automation takes care of the rest. Finally, trust and transparency comes up again and again around automated control. And once the consumer's installed a bidirectional charger, they need to be confident that it's going to work and deliver the energy they need. And that also their data, so we've got connected systems and all the data here, that's safe. So across Europe, we have the GDPR data privacy framework, which provides a really good industry practice around this. And we also need to ensure that consumers can sign up to V2X operations safely and easily. So this research has been really pivotal in our approach to unlocking the barriers to V2X energy flexibility. And we're now going to look at the 8 industry actions that will help unlock a V2X future. So let me just talk you through how we've created this roadmap. On the left-hand side, we've got the 5 consumer needs that we just spoke about on the previous slide. And then across the top, we have the 5 industry stakeholder groups that need to work together and collaborate to unlock the potential of V2X. So there's 8 industry actions that we've mapped out that map to these consumer needs and the industry stakeholders responsible for leading them. So if we go through those one at a time, the first is in order to provide attractive compensation to consumers, we need to improve access to power markets for EV energy flexibility. So this primarily sits with electric utilities, but also the regulators who govern them, and is really key to unlocking what Nick showed at the beginning of the presentation, where we actually want to reduce peak demand on the grid. We can create huge value for electricity networks, but we need the markets and programs in place that allow this value to be unlocked and passed back to end consumers. The second action that's also with utilities and regulators is to enable service stacking between different flexibility markets to maximize the value for consumers. So EV flexibility can deliver value to utilities at different levels of the energy system. So at the local distribution level, at national transmission level, managing grid constraints, and also whole system balancing. And these markets need to be accessible so that different assets can participate and add value across the energy system. The third area the third action needed to provide attractive compensation is the development of new electricity tariffs and rates. So energy retailers here play a really crucial role. Traditionally, Nick mentioned as well, time of use rates, where you have a static time of use rate, which is kind of the most basic form of this, but risks of secondary peaks. We're now working with utilities looking at dynamic time of use rates and how we can actually do type of use. So we get all the benefits of a dynamic time of use rate in terms of optimization, but we simplify things for the consumer and the end customer, maybe giving them a fixed price of electricity or rewards and discounts in return for allowing a platform to control and the utility to benefit from flexibility within their charging schedule. Addressing the second consumer need of affordable and available charging equipment. Key to this, step 4 is offering consumer-centric V2X propositions. As Danica said, the bundled offers are really attractive in this space, and we need to ensure that automakers, charger manufacturers, charging platforms, energy retailers, that quite complex value chain works together and collaborates to offer consumer-centric propositions. Once a customer buys a bidirectional charge point, they need to get it installed. And connecting that charge point to the grid can be a real problem. The UK is actually doing quite well now and has gone through a lot of iteration of this process, where when applying to connect a bidirectional charge to the grid, the network has 10 days to respond and offer that grid connection. Otherwise, they get a potential fine from the regulator. So that process has definitely moved forwards. In some parts of the US, this interconnection is still a massive challenge, and people can be waiting weeks or months in order to get things installed. So as we want to scale and ramp up this whole industry, making the install and grid connection process simple is going to be very important. To ensure the safe operation of battery and vehicle, one of the key challenges highlighted is the importance of certifying battery warranties for V2X operation. And we're working with several OEMs at the moment discussing how we can provide them with more data, which is needed to build confidence in understanding that there is very little, if any, battery degradation, provided that export of energy from the EV battery is controlled within certain parameters to protect the battery. And this is going to be really key for consumer uptake. The final two are more across the whole industry in terms of shared responsibility. So Giulia mentioned the importance of standards that are needed to result in interoperability and that seamless user experience. So these standards are often led on by governments or regulators, but actually broad industry engagement is really important to make sure that they're deliverable and effective. And finally, for trust and transparency, communicating clearly and consistently the benefits of V2X technology is really a joint and shared responsibility, I think, with everyone across the sector. We've already seen some challenges and kind of pushback to electric vehicles and misinformation in the media. We just need to make sure that we're being really clear and consistent with how V2X is portrayed, and so that consumers can have trusted information around the benefits. So now we've shared the V2X roadmap for industry action, I'm going to hand over to Sophie Randall from Innovate UK, who's going to talk to us about how they're driving forward innovation.
Thanks, Will. Yeah, so for those of you that don't know, my name is Sophie Randall. I'm the Innovation Lead for Mobility and Cities at Innovate UK. And as Will mentioned at the start, Innovate UK are the UK government's innovation agency. We act to support UK businesses to develop new products, services and business models to help support the UK economy. We work very closely with Innovate UK KTN, our knowledge transfer network, and Innovate UK Edge, our commercialisation and growth specialist. So if you want any more information or support on that, please do check out our website. Could I have the next slide, please? Perfect. So why is this all important to us and what has been done so far? Electricity demand is forecasted to vastly increase through the transition of combustion engine vehicles to electric vehicles, alongside the electrification of other forms of transport and areas such as heating and manufacturing. Therefore, we need to identify and develop innovative solutions to support the grid by balancing the supply and demand and making the most of that sustainable energy sources where we can. In order to address this, funding has been made available to support electric vehicle charging innovation since 2018 and will continue through until 2025. Now, this has transitioned from the Vehicle to Grid programme, which was and still is one of the largest and most diverse programmes of vehicle-to-grid activity in the world to date, through to the more recent Vehicle-to-Everything programme. Lessons from the Vehicle-to-Grid programme helped to inform policy work and support the V2X call for evidence, which led to creating that enabling environment for Vehicle-to-Everything. Now, alongside this, innovation has been supported by strategy development. So the Smart Systems and Flexibility Plan and the EV Smart Charging Action Plan have set out UK government and UK energy regulators' intentions in the smart charging space. Now, just to note, lastly, the current V2X funding is part of a wider flexibility innovation programme, and this is delivered by the Department for Energy Security and Net Zero, and is seeking to enable large-scale, widespread electricity system flexibility through smart, flexible, secure and accessible technologies and markets. Could I have the next slide, please? Perfect, thank you. So what have we learnt so far? Well, the V2G programme, which saw over 650 bidirectional chargers installed in UK homes and workplaces, offered us a number of insights. Firstly, it demonstrated that V2G is technically feasible. However, it was limited to CHAdeMO charging technology only. It also showed us that using bidirectional charging can produce viable commercial propositions and can help consumers achieve energy savings and therefore cost savings. However, from the programme, it was evident that there could be more value in expanding bidirectional charging technology into vehicle-to-everything. And there was also the potential to explore beyond CHAdeMO into the other charging protocols that are on offer. So this has led to the current ongoing V2X Innovation Programme, which is split into a two-phase competition. So phase one, which is currently undergoing, is looking into developing prototype hardware, software or business models. And phase two, which is currently under assessment at the moment, will be looking at small-scale demonstrations. So these will be investigating real-world use cases with real-world drivers. Now, it's been mentioned before, but just to note, all of these programmes have been collaborative. We strongly believe that the whole sector needs to work together in order to address energy demand and enable the flexibility needed as we undergo this vast electrification. Next slide, please. So just lastly, our international intentions. The UK is a great place to innovate and do business, and there is a huge ambition for UK businesses to become international. And in 2017, Innovate UK established its Global Expert Missions, sometimes referred to as its GEM programme. Now, these are delivered by UK KTN, and they're in partnership with the UK Science and Innovation Network and the Department for Business and Trade. Now, GEMS help to further Innovate UK's global strategy by providing the evidence base for where it should invest and by providing the opportunities for UK businesses to build partnerships and collaborations with key international economies. Now, the UK is already showing itself as a world leader in the V2X and V2G space, with a number of world-leading businesses, some previously mentioned, located right here in the UK. So we need to take advantage of this head start and build upon it. Therefore, in a few weeks' time, Innovate UK will be running a smart charging and V2X global expert mission to California, and they will be seeking to identify opportunities for bilateral collaborations between the UK and California. Following this, a summary report and public dissemination event will be organised, and that will be approximately 12 weeks after the mission, and this will outline the next steps for UK businesses. So depending on the findings of the mission, it may lead to further global programme support to build collaborations and partnerships within the US market. So it will be good to see the outcomes of that. And lastly, I just want to mention our V2G hub. So this is a website that shows all the V2G activity which is happening across the world, and it's currently expanding into V2X as well. So please take a look at that, and if you feel that there's a project missing or things to be added, then please add onto it. I'll be handing back to Will then.
Thank you, Sophie. It was really great to see Innovate UK's approach on how you're helping to drive this innovation forwards. Now, in the few minutes remaining, we're going to pop over to New York, where Joe Stilin, who is Director of Utility Solutions at EV.energy, is going to tell us a bit about the global opportunities for V2X and specifically focus on some of his work with utilities in the US. So Joe, there's lots of exciting projects happening in the V2X space around the world. What are some of the opportunities that you're seeing?
Yeah, thanks, Will. And building on, next slide, please. Building on Sophie's talking about with innovation in the UK and V2X, here's some of the utility partners that EV.energy has been working with. We're working globally with utility partners around the UK, Europe, North America, as well as Australia. And so we've been building on our experience working with this global network of partners to identify and learn best practices on how we can unlock the maximum value both for drivers as well as our utility partners. Next slide, please. So as Sophie mentioned, the UK is a hot spot for V2X innovation so far. There have been over 26 V2X projects undertaken in the UK, and North America is quickly catching up on the heels of that, with several projects being undertaken by utilities and other institutions in the US. So you can see that both of these areas are innovating and building on V2X in their respective regions. Next slide, please. So I just wanted to focus on our work here at EV.energy with utilities in the US for a couple minutes. We run lots and lots of managed and passive managed charging programs throughout the country and North America. So those are V1G, level 1 and level 2 smart charging programs. The V2X in the US, the primary use case is most likely going to be preventing those critical peak events that cause, at the worst case, blackouts and everyday kind of timer peaks that get caused by, time of use rates and lots of vehicles coming onto the grid at once. So through our experience working with our utility partners and the residential EV charging programs that we put out, we have learned quite a bit about driver behavior when folks are charging, when they're plugging in, the kind of export potential that we have. So looking at how much charging is actually being done, and then how much time is available for V2X to export to the home and or to the grid. And working with some of our utility partners, including Southern Company, we've been looking at the data that we gather in these programs, and we're able to kind of identify the next steps and what the future with V2X could look like as we potentially layer V2X into our program. So we're learning about how to make this experience as easy as possible for utility customers, making it make economic sense for those customers, and also identifying just the hard results of how this can benefit utilities.
Brilliant. Thank you so much, Joe. So as you can see from the webinar today, there's lots of activity happening, but also still a lot to be done. We've introduced V2X and how the ecosystem connects. And this presents a really huge opportunity for the actors across the value chain. And V2X is also a key technology enabler to unlock the green renewable energy system. The consumer insights have shown us that putting consumers at the center of V2X propositions and understanding the different drivers and motivations of end customers is really critical for V2X being adopted as a mass market solution. And finally, collaboration is really key to driving forward V2X technology across the world. And we hope that the 8-step roadmap that we presented provides a really helpful guide that can help focus that collaboration as we look forward to continuing our work with charger manufacturers, OEMs, and utilities, along with governments and other organizations to really help unlock the V2X future. In terms of timing, we're 1 minute past the hour. The panelists may be able to stay on for a few more minutes to answer a couple of questions. Otherwise, if you want to pop them in the chat or alternatively email innovation@ev.energy, we'd be really happy to take those questions away and continue the conversation. Giulia, Escher, are you still with us?
Yes, I am.
Great. Well, there's one question come through. I appreciate that some people need to drop. That's absolutely fine. The webinar is being recorded as well, and so we can share that recording and responses to broader questions. We'll just take a few minutes now to answer one or two before we close the session. There's one here from Marcel Caiger, which is asking about your view on a fourth case for V2X, which is vehicle to building, and how this might apply to a workplace setting.
Yeah, very good question. And actually, thank you for pointing it out. I think we kind of highlighted the three main kind of use of V2X, but it's completely true that those are not the only ones. I think Keenan, our colleague, has already kind of mentioned a few comments in the chat, but I'll just add to that. It is a very interesting application as well. I guess there is probably some work to be done there around the kind of consumer proposition. I think maybe potentially Will or Danica can add something about that, but it is definitely I see probably the use of it more for like a fleet scenario than a workplace, because at least personally I can't it's quite a difficult sort of optimization where like users might be charging at home with their own electricity and then discharging into their office. But for example, we have done some talks with people that manage fleets, for example. And so there where you've got like a building and your fleet in the parking lot next to it, and the fleet is probably standing at the office for many hours, not necessarily during working hours, probably overnight as well. So there is definitely there some optimization that can be done, and it is actually part of the work that we're doing with Innovate UK to look into vehicle to business solutions as well.
Brilliant, thank you, Giulia. There was also a question to Joe Stilin about, are those in order of consumer preference? So I assume that was referring to your last slide.
Yeah, thanks for the question. Yeah, not necessarily. I think we'd have to take a look at maybe Danica's research on that. I think the order of whether critical peak or blackout protection from those events, and then consumer preferences, which order those go in, those are related. I think to be clear, blackout protection and identifying consumer preferences are both super important. So we can take that question offline if you'd like and chat about it further.
Brilliant, thank you everyone. We're coming up to 5 minutes past now, so I'm going to close up the session. But I'd like to say a huge thank you to all the speakers who have contributed to the session today, and to also all our project partners and other commercial partners who we work with, who have been working with us on V2X Flex and other projects. I hope you enjoy the rest of your afternoon, evening, or morning, depending on which time zone you're dialing in from. And yeah, looking forward to this being the start of more conversations as we work on unlocking the potential and the future of V2X together.